Hello everyone, I am Gaurav Patil, along with the team members Pranav Chalasani, Anshula Nandanwar and Faizan Khan. So today we are here to present our project on the title Semantic Segmentation of Water Bodies in Satellite Images and its Performance Evaluation. This project is conducted under the guidance of Pranali Dhavas and supervised under the guidance of Professor Achama Thomas. About the water bodies are certainly a distinguishable part on the surface water, such as lakes, streams, rivers, and part of streams or river can be considered as a water body, and this can be easily distinguished from any satellite images. When we look from the top view of the Earth, water bodies are important. They have a lot of important perspectives in nature, such as water can be water are provided to the people to drink, and they are an important part of our biodiversity. The water bodies also affect the climate change, and the ecosystem is driven through the water. Without water, there will be no living being on the earth. And hydrological cycle is also depend on the amount of water that Earth have, and also the people living around the water bodies depend on the resource management of water. Um, Therefore, water has a significant importance in the living of people, in the living lives of people. Now, if there is any spatial or temporal change in the pattern of the water surface water has so it makes a significant impact and has a lot of scientific values. Therefore, it is necessary to monitor the changes in the surface water. There is one technology, remote sensing technology, which is efficient and convenient mean for identifying the surface water at a very large scale. Um, a large number of water bodies extraction methods are available using this remote sensing data, which are proposed over a few decades. But most of them are manual or very costly. Therefore, there is a need of automation for detection of water bodies. So our objectives in this research is to advance the research of water body segmentation in satellite images. Therefore, we are proposing a deep learning based image segmentation technique for this, which will be based on advanced computer vision, which will overcome the shortcomings of traditional computer vision and machine learning techniques. And here we are going to implement the advanced image segmentation algorithms like Unet and along with its backbone. And thereafter we are going to compare that with the existing algorithms and trying to show what best could be the fit for this task. So this is a literature survey on the previous research that researchers had did. So one of the researchers have presented a comparative study of water index, machine learning classification, and multi-layer perceptron technique for identification of water bodies in Landsat satellite images. And then another research has been proposed where the author has used a variant of detectron true for instance segmentations to detect the water bodies and compute the changes in that area for the time lapse Sentinel-2 satellite images, which are captured over 32 years from the year 1984 to 2016. Then also research has proposed a unit-based method and transfer learning based method over per Perusat 1 satellite images. Another research has been proposed where authors has automated the image analysis techniques, which are capable of extracting the amount of water from a picture, which can be used to create a novel service amid to detect flood. So this is the proposed method or the system architecture that we have built. Uh, so this is a state-of-art method. The algorithms that we have used are Unet plus ResNet as a backbone, Unet plus DanceNet as a backbone, Unet plus Inception ResNet as a backbone, Unet plus VGG16 as a backbone. And to evaluate those, we have used IOU score and Jaccard loss. So from the architecture diagram, there is a data set. We have split the data set into train and test sets. Then we have implemented our train and image segmentation algorithm over the training set. We have evaluated those by creating train and validation sets. Um, we have saved the weights. Then the saved weight were tested over the testing data set, and we got some predictions. Using those predictions, we have calculated the IOU and I scores. So these are the results that we got. So from the method, a simple unit method gets an IOU score of 47.26 over the training data set and so testing data set and training data set, and over the testing data set it gets 48.90. The prediction time was pretty quick, that is 51 milliseconds for a single image. So along with a backbone of VG16, using the algorithm Unet, we got a training IOU score of 48.98% and a testing of 52.12%. The prediction time was a little high just because the backbone adds complexity to the model. So the prediction time goes to 61 milliseconds. Uh, the next model, Unit plus ResNet, has a training accuracy IOU score of 48.98 and testing is 27.91. The testing accuracy of dropped significantly just because the model was too complex over the dataset. The prediction time is also quite high, that is 2 seconds. The model Unit plus DenseNet 201 has a training accuracy of 50.11%, 11%, and over the testing, the IO score goes to 26.14%. The prediction time is 2 seconds. The new model Unet Plus Inception ResNet V2 has a training IU score of 63.03% and testing IU score of 28.42%. And the prediction time taken is 2 seconds. So below diagram shows the original image, actual mask, and the predicted mask. So the leftmost image is the original satellite image that we have got, and the middle image represents the mask that our model is trying to predict, and the right most image is the mask that is predicted by our algorithm. So this is the predictions we have got from the Unit plus VGG 16 model. So the highest accuracy that we got in terms of training or training dataset is from Unit plus DenseNet 201. Unit plus Inception ResNet V2, just because of complexity of the model, and the highest testing accuracy that we got is from the Unit plus VGG 16 model. So the hardware and software utilities that we have used is Jupyter Notebook and Google Colab for training our model over the GPU, and we have used Kaggle website for collecting the dataset. So the technological stacks include implementation of Python libraries like MATLAB, Seaborn, Pandas, and TensorFlow. So the conclusion of the project is that we have automatic water body detection is an important task to identify its spatial and temporal change patterns, which has significant effect on the large number of people. As we have explained in the first slide, we proposed and compared few image segmentation techniques for water body segmentation in Sentinel-2 satellite images. We found out that the VG Unit plus VG16 method has the highest IU score over the testing dataset. These are some of the references that we have collected from. Thank you. So about the implementation part, so the simple unit model. So this is the some of the satellite images that we have collected, and this is the sample mass that we have got from the dataset. We have implemented a few augmentation techniques like resizing and splitting the channels. So we have just considered a single channel, and together total we have 2841 images that we are used for the experiment, which are further splitted into train and test set. So the training data set has 2272 images, and the testing part has 569 images. So the model was trained over the simple unit model for over 50 epochs, and at the 50 epoch, we got an IU score of 47.26 over the training dataset and 28.90 over the validation dataset. So this is the training and validation loss graph you can see. So the loss keeps on going downwards, and this is the accuracy graph, and you can see the accuracy kept moving upwards. These are some of the sample predictions from our unit model. Similarly, all the statistics were kept the same, and uh, we have trained the model for 50 epochs for unit DenseNet 201, and this is the IOU score for training dataset, and the testing dataset, this is the IOU score. So these are the graph that we got, validation loss, and so these are some of the sample predictions. So similarly, in the case of ResNet, all the things remain the same. The model was trained for 50 epochs, and these are some of the few sample predictions that we have got. These are included in the part of thesis as well. So these are the sample predictions from the Unet VG16 model. Yeah. So this is our demonstration of the project. Thank you so much.